Hello, everybody. It's that time of the week again. Welcome back to Alex Does Lead Code, where I do programming problems on stream together with you. Okay, let's jump in right away to where we left off the last time. Come back to my list. Next, valid Sudoku. So we may not end up doing this today. Let me take a look at it. Yeah, we actually might not end up doing this today because, unfortunately, I have to leave. I have to end my stream early today, so give me a second. So let's do something else. Let's do something else this time. So we can so I can get to my next appointment on time. All right, let's pick an easy one from something that is not that. Okay, let's try this. Unique number of occurrences. All right. So a new feature new change that we did to this channel since the last time is that I have turned on chat. Apparently, my channel was set to meant for kids. In some sense it is, but in some sense it really is not, unless you're Sheldon Cooper. So I switched that off, and magically my chat worked again. So I am able to see things in chat. So jump into chat. Say hi. Hello, everybody. So that's, as usual, there's a small bit of latency. We'll see how it goes. All right. So unique number of occurrences. This question number 1207. Let's read it as usual. Given an array of integers r, return true if the number of occurrences of each value in the array is unique, or false otherwise. So let me just check real quick. This is supposed to use a hash map set. The idea is you have a list of integers like this, and you want to see if each value, if the number of occurrences of each value in the array is unique or false otherwise. Oh, okay, we're not looking for unique numbers. This is a very weirdly phrased question. Basically what it says is the following. You take the array, you count how many times each number appears. So 1 appears 3 times, 2 appears 2 times, and 3 appears 1 time. Okay? No two values have the same number of occurrences. Okay? So you count how many times each of these guys appear, and then check that the number of occurrences is unique. So we're not looking for the values being unique. So you see here 2 appears twice, that's fine. Okay? We don't care if the values themselves repeat. We just want to make sure that the number of times they repeat are unique. So in this case, for instance, 1 appears 1 time, 2 appears 1 appears 1 time, 2 appears 1 time. So this one and this one, this number of times they appear, that's the thing that we're looking for. That's the uniqueness we're trying to check for. Okay? This weird I'm trying to think about what real world applications this might have. I can't think of any. But you know what? Either way, let's try to solve this problem. So what is the first step we want to do here? Well, I think the first step is fairly straightforward. We want to count the number of occurrences each value has. So to do that, we're going to use a hash map. I think this is the first time I've used a hash map on this channel. I'm not going to explain it. We're going to do a separate video on what a hash map is some other time. But for now, we're just going to use it. We're going to create a hash map. And because its job is to count the number of times a value has occurred, let's call it occurrences. and a hash map looks like this. It starts with nothing. Okay, so we're gonna look through this R, and we're gonna populate the hash map. Now, because the hash map starts off empty, there are two possible scenarios. One, okay, so let's say n here. The first value of n is 1, right? So there are two possible scenarios. A, occurrences does not contain n, in which case we say if occurrences does not contain n, then this is the first time we have seen it. If it does contain n, then we increase the count by 1. So if this is the very first time we've seen it, occurrences is not, if n is not in occurrences, this means that this is the very first time we've seen it. Okay? Then we just set occurrences n equals to 1. So we've seen it one time. This is the very first time we've seen it. Else, plus equals to 1. Otherwise, we increase the count by 1. So that's it. That's all there is to it. And that is sufficient for us to get a count of all the occurrences. But here's the thing, we're not done yet. So at the end of this occurrence, will look like 1 has 3, 2 has 2, 3 has 1. So there, for number 1, it occurs 3 times. The number 2 occurs twice. And number 3 occurs once. This is what occurrence will look like. Look something like, obviously these are not the actual values. These will be the actual values if the input is this. If the input is something else, then it'll be completely different. So if the input, for instance, is this, -3, how many times does -3 occur? 1, 2, 3, 3 times. 0 occurs 2 times. 1 occurs 1, 2, 3, 4, 4 times. And then 10 occurs once. Right? This is the occurrence hash set, hash map. This is the occurrence hash map. Or in Python, we actually call this a dictionary. I think, it's a great and also not great word for it. But I like it. I like the word dictionary. Hash map has other connotations that I dislike. It's too implementation focused. Okay, cool. So now we have this. What's the next step? Next step is want to check among the values. So these are the values, these occurrences. We want to check if these things are unique. And in this case, the answer is yes, because 3, 2, 4, and 1, they are unique. So it returns true. Now, note that at this point, we're basically going to discard the values themselves. The numbers themselves go away. We just look at the number of occurrences. Okay? So the way to get the number of the values in a dictionary in Python is dot values, and I'm pretty sure Python list unique. There is a built-in function I'm pretty sure there's a built-in function to do this. Okay, I'm pretty sure there is a built-in function that allows us to figure out if this is unique or not. And I think, let's see what unique does. Unique values from a list. Okay. Well, let's do it. Let's get the unique values from the list. Okay. It's not exactly what we want, but we can use it. So the way to do it, so let's think about how we want to do it. Okay, and here's a little puzzle. I deliberately took my time here to let you think about how you use this dot unique, which gives you the unique set of values in a list to help you check if the list is all unique. Well, the answer is we check the length. If the length of the original list equals the length of the unique list, which is basically if we remove all duplicates, it means that no duplicates were removed. Dot unique removes duplicates, it means that no duplicates were removed. If no duplicates were removed, then the answer is true. Well, we can actually do return this. Right, let's run it and see what happens. Oh, I'm sorry. Dict values has no unique. Oh, so you can't use this. Values into set. This is only for lists. It's I think you can do this. Turn this into a set. Okay, perfect. So set basically turns. It does the same thing as dot unique, but it turns it into a set. Dot unique it takes a list and then turns it into a list. Now, let's submit this and see what happens. Yeah, well, it's sort of medium. Okay, cool. Now, I want to say a few things. Say a few things here. Let's talk about this. Yeah. Let's talk about why occurrences dot values dot unique did not work. And the reason for this is there looks like a list, but it really is not. It really is not. And this actually happens a few times. It has actually happened more than once on stream, much to my personal embarrassment. Okay? So for instance, let's say D equals to 1, 1, 2, 2. I just want to construct a very simple dictionary. Alright, print class dict. if I print the type, actually let's just print both keys and values. Dict keys, dict values. These are class objects. This is really interesting, right? This is really, really interesting. These are not lists, but they are class objects. So I want to check if they are iterable. Python check if class is iterable. Object is iterable. Iter some object. Okay. Okay. Versus L equals to 1, 2, 3. If I print the type of L, the type of L is going to be a list. The type of L is a list. So even though even though d.keys and d.values look like lists, they are not actually lists. In fact, let me just print them out to show you how much they look like lists. Okay. This is key.keys. Oh, this look like value. This looks like lists, right? You see these? These look exactly like lists. So this stringification function actually does a good job by saying that this is not actually a list. It's a dict value that looks like a list 1, 2. So these are not actually lists. Another thing that looks like a list but it's not actually a list, and I got tripped up by this before, is range. Do you have X range? I don't know if X range is still supported. So if I print R and I print the type of R, you will see that R is not actually a list. R is range 0, 3. So it's a range from 0 to 3. Why is this important? It's important for a few reasons. One, making these things lists is rarely the right, how do I say? It's often not the right move. Making these things lists is often not the right move. Take, for instance, range. I think this is the most obvious to explain why it's not the right move. Suppose you have range 300 or 3 million, right? If you create a array, a list, it will be a very big list. It was going to cost you 3 million bytes, which is 3 megabytes. But you don't want to do that because ranges, the assumption is normally you put a range at the end of a for. At the end of a on this side of a for loop. So this means on this side of the for loop. So this means that you don't actually need to use every single element at once. In fact, most of the time you just use element 1 at a time. So if you do this, if you make range clever enough to feed the next element every time you ask for it, then you don't actually have to keep every single element. You don't need to randomly access. I'm never going to ask you for, R is range. I'm never going to say print R 500. I'm never going to do this. In fact, this does not work because R is not a list, right? So range does not need that random access property. That's why it's very inefficient for ranges to be stored as lists, especially very large ranges like these. Instead, all of these things share a common property. All of these things, let's go back to my here. It is a key. It's a dig key. Is that what it's called? It's a dig key object. A dig value object. Is that what it's called? Where am I? Let's visualize it. Well, let's get the proper name for it. Is a dict underscore values object. Is a dict underscore values object. Is range a list? It is a range object. You can find this out by using the type. The type function would return the type. Will return the type of the object. However, all of these things, dict key values, list, range, and even dictionary itself, all share one property, which is iterable. And to demonstrate this, we're going to say we're going to print all of these things share the same property, iterable. Iter d. It should. Let me see. How do you do this? Not this. Yeah, so iter this element. That's the best way of doing it. Yep. Or has attribute iter. Something like this. Yep. So all of these things share iter property. So you can run iter on it. Print iter, print iter r, print iter l. And you can see that all of these work. But if I print iter 5, that's not going to work because the number 5 is not iterable. So watch this. There. Type error. Int object is not iterable. This one. It fails here. So this is not exactly the most graceful way of checking if something is iterable. You actually have to call a function and then try catch an error. You can't actually say, hey, is it, you know, it's kind of weird. You can't ask if this is iterable. You have to try it and watch it fail. That's how you know. Okay? So all of these share a property, iterable. And that iterable property allows it to appear here on this side of the for loop, among other things. Iterable means that it will, you can ask it for many things and each time it'll give you a different thing. You can sort of iterate over that. So list, dictionary, they all. Right, you can write your own class, your own object that is also iterable. It doesn't always have to give you a different thing. It just have to give you something. So you can make a object that just gives you the number 5 forever. And that's iterable. That's fine. So long as it implements the right functions. I don't remember exactly which function. I guess it's the iter function. I'm not super sure. I guess someone mentioned here is the get item. Yeah, the get item function. Yeah. Okay. So that concludes today's mini stream. It's 10:30. I got to go, unfortunately. Well, either way, thank you all for tuning in, and I hope to see you next time. Next time we are going to work on the actual problem that we highlighted the last time, which is valid Sudoku, and that'll be next Wednesday